Okay, so we talked about partial sums sequences in the last section. So now we'll get to partial sums of arithmetic sequences. And we'll start with, this is actually kind of a famous problem in math, to find the sum of the first 100 numbers. And so we can come up with a formula for this, and we'll have a formula for other types of sums like this, but we'll just kind of illustrate what's going on here. And actually, let's write a few more terms in here. So let's say 1 plus 2 plus 3 plus all the way up to 98 plus 99 plus 100. And so we have all the numbers in between. And so if I want to do this quickly, obviously, it would be fairly tedious to just put those all in the calculator. So there probably is a formula that we could get. And one thing you can notice is if we kind of group these terms together. So in addition, as you probably know, you can add in any order. So if you have 1 plus 2 plus 3 plus 4, you can add the 1 and the 4, the 2 and the 3, and then add those two sums together, or you could add the 1 and the 3, the 2 and 4, add those sums together, or whatever order you want. The order doesn't matter. So what we can do is we can get the first term and the last term, and we can get the next two terms together. We can get the next two terms together. We can follow this pattern all the way till we get to the middle. And then we would have 50 and 51 grouped together. And if you notice, 1 plus 100 is 101. 2 plus 99 is 101. 3 plus 98 is 101. And so as we move in, every pair of numbers that we put together, the sum will be 101. So how many of these do we have? Well, so I kind of gave it away in that the middle pair will be 50 and 51. So we start with 1. The first pair starts with 1. The last pair starts with 50. So that would be 50 pairs. So if we do 50 times 101, that would give us 5,050. That would be the sum. Now we can get a formula for this. So if we added 1 plus 2 plus 3 plus ... all the way up to n, whatever n might be, n plus 1, that's where the 101 comes from. So we ended at 100. We have 101 in the formula because wherever you stop, so we stopped at 200, it'd be 1 grouped with 200, so 1 plus 200, and then 2 plus 199, and so on. Those groups would each, or the pairs would each be 201, which is 1 more than n. So that's where the n plus 1 is. Now this is actually half of whatever the last number is. So we can n over 2. So this is actually the formula for the sum of the first n integers. Now you don't need to know that, but it could be useful at some point. But what we're more interested in are these arithmetic sequences where we have a plus d plus a plus 2d plus a plus 3d, and so on, all the way up to n minus 1 times d. And we won't derive these formulas just for the sake of time, but either one of these formulas will work. And you notice we kind of have the n over 2 still, but since this is not a counting sequence where we're 1, 2, 3, and so on, this could start on any number. So you start on 4, and then you could add 7 every time, for example. So 4, 11, 18, 25, so on. Whatever the sequence is, you can use either one of these formulas. I kind of prefer to use this one, but either one you can use. And so let's find the sum of the first 50 odd numbers. So that would be 1 plus 3 plus 5 plus ... Now, where would it end? If you have trouble with this, you could, so the arithmetic sequence formula is that the first one is 1. That's the first number in the sequence. The common difference is 2. and then we are going 50 terms, so that'd be 50 minus 1. And so that tells us that the 50th odd number would be 99. So we're going to go all the way up to 99. And so there's our A, there's our AN, and then the difference would be our, well, actually we don't need the D. Don't need the D, so don't worry about that. And then of course we have 50 terms. So S50 in this case would be 50 times 1 plus 99 over 2. And so that'd be 50 times 100 over 2, or 25 times 100, so 2,500. Now, just as an aside, this is just kind of an extra little math tidbit. The odd numbers actually equal however many odd numbers you have. The sum of the odd numbers is that many odd numbers squared. So this would be 2 squared. So we have 2 odd numbers equals 2 squared, which is 4. You have 3 odd numbers. Whoops. You have 3 odd numbers. 1 plus 3 plus 5. Now that is 9, which is 3 squared. You have 4 odd numbers. And that is, you could work that out, but that is 4 squared. Add a 9 on there, that'll be 5 squared, and so on. So that doesn't help you in any other problem besides this one. But if you add up certain number of odd numbers, however many odd numbers you have, the sum will be that n squared. So and same thing in this case. So we have 50 odd numbers. 50 squared is 2,500. So don't need to know that other than just for kind of general knowledge. But if you have any questions, feel free to email me.